Yeah, welcome to this session number 91 of SQVE Structural Summit. And today we are going to have interesting discussion on 30 plus story tower, which collapsed unfortunately on 20th March 2025 during the earthquake event, right? And thereafter, a lot of discussions initiated in the structural engineering community in the various forums. Right? And there are different reasons floated here and there, right? So that's what we are going to discuss here today. Of course, as we all know, that definitely requires a very detailed forensic investigation. But whatever information we have, which was rather captured through CCTV camera from different angles, right? That's the basic information we have, right? And from different social media platforms, a few information has been collected, and that's what we will discuss. So this entire session is divided in several parts. Firstly, we will have a quick look at different clips, which you must have seen a number of times, right? Then through registration form, we in fact ask about what may be probable reason for failure of this structure, and everyone has mentioned interesting reasons. Of course, again, I'll mention here that detailed forensic investigation is required. But what may be probable reasons for collapse of these structures? That's what we will discuss. And along with, we will try to learn from failure of this structure. Thereafter, in the third part of this session, or whatever clips I've collected from different sources through the social media, will be running, or rather, I've created very slow motion video, and we'll try to capture the failure. We'll try to see. And there are a few interesting things which I've observed while going through this different clips. So that's what we will discuss. And thereafter, we will have open discussion on this failure, right? So this is the way we have planned this entire session, right? So let's start now.
Welcome to SQVE Structural Summit. We are very much thankful of you for participation in the live discussions. Please subscribe to our YouTube channel of SQVE Academy and press on the bell icon. You will receive notification for the future events when we go live. Also, kindly like and share the video with the engineers in your network so that more numbers of engineers may be benefited. We are planning to come up with more and more important and informative videos. To support the initiative, you may join our YouTube channel of SQVE Academy with nominal monthly subscription. In return, you will get access to member-only videos at YouTube and the other perks. The subscription can be cancelled at any time. Step-by-step approach to join the YouTube channel is mentioned on the screen. For any doubts, you may get in touch with us through email address. Thank you.
So what I've done, there are different footages available from different sources, as I just mentioned. And based on my understanding, I have defined this view like view number 1, view 4, view 3, view 2. So this is the building under discussion, 30 plus story building, right, which was under construction. And the different footages which we have. So as per my understanding, I have divided this footage in the 4 views, right? So first of all, let us see what are these 4 views. Let me just open. Okay, let us open it here. Here it is. Okay, this is what I have said as a. So this is the view number. If I just put it here, right? Okay, so first of all, this view I've considered as a view 1-4. So we are looking from this direction. So this is side number 1, and this is side number 4. Okay, so we are looking from this view. So that is view number one and view number four. I have said here, right? So right now, we'll just put up this quick clip in this in the very fast motion or in the real time motion, and of course in the next part of this session, we'll run this clip on the slow motion. So here, okay, so now it's not running. Okay, here it is. Okay, so this is the view number one and four. And from that side, here we can see some failure, right? And then suddenly it collapses. Of course, we'll see this, we will try to analyze this clip in a very slow motion in the next part. So this is one of the view number one and four. Second view, let's see, what is view number two? So in this view, what we could see, of course, the view I have decided, or rather I would defined based on my understanding, based on the limited information what we have. And those, one of the information what we have from this clip, that there is a position of the crane here, which we can see in the top, right? So this is side number one, as we said, this is side number four. And opposite to this is our side number two, right? And in this back side, this is side number three. So let's try to see the view number two. So this is view number two. Now in this view number two, of course, as we can see that the crane is not visible, so it is in the back end. And okay, so here if we just stop at this point, yeah, so here and now in this part, the crane is coming out. So that's why I consider these as a view number two. So we have seen view number one, view number four, view number two. We also have one clip which is view number three. So just let me put up that also. So this is view number three. Okay, now here, when we just see this clip, so we can see here the crane in the position, and now we can see crane here starting from left side to right hand side. So that's why it becomes our view number two. Sorry, not two. It's actually our view number three. It is our view number three, right? So this is the way firstly I have just started analyzing these different clips, which is view number one, two, three, four. Of course, we'll see very closely all this clip in a slow motion, and there are a few very interesting things for our learning purpose. So we will discuss those things in detail. Okay, someone is saying that screen is not visible. Okay, no problem. Is my screen visible now? You can mention in the chat box. Okay, so let's say I was just trying to show view number one, two, three, four. So how many views you have seen? One, two, three, four. You just put up in the comment box, or what is the view which you have not seen? So then I'll put it up on the screen again. Okay, view two is not seen. Okay. Okay, let me open view two. So right now what we are looking is, this is view number three, right? So view number one, four we have seen. This is view number three. And let me put up view number two. Yeah, so this is the view number two. Okay. Okay. So I hope you are able to see view number two. Just simply mention yes or no in the comment box. I hope Priyanka is able to see the view number two. Okay. So these are the four views we have. If you can go back to this image, the one, two, three, four, right? And we'll try to analyze all different views after a few minutes. So before that, in the registration form, we asked about what may be probable reason for failure of this structure, and everyone has raised or rather shared very interesting point. And of course, as we discussed that in absence of forensic investigation, detailed forensic investigation, I would say, it's very difficult to identify that which is the reason for failure for collapse of this structure. But of course, for learning purpose, we can always study this kind of failure, and failure and learning from failure is one of the greatest source, right, for the learning purpose. So that's what we will try to see. We'll try to have a look into what are input we have received so far. So I hope you're able to see the screen Excel file. I've just opened I've collated all input, whatever you sent through the registration form. I've just put up those into the Excel file. Right? Let's have a quick look at to all the different causes, right? And probably you can just mention into the chat box that are you able to see the Excel file on the screen? Simply mention yes or no, and then we'll start. Okay, great. So McDonald is saying that poor structural analysis. Chandra is saying that faulty design and non-implementation of the codal provisions. Samiron is saying that soft story, right? Nikhil is saying it is maybe related to soil. Samim is saying sob story. So, in fact, we have received responses from different parts of India, as well as we have received responses from outside India also. Abdul is saying that no care during construction. So, that means fault into the construction. Structural failure. Selva is saying that, okay, Vijay is saying that higher magnitude compared to the design criteria. So, whatever load for which structure was designed, then the actual force was higher than that. This point is mentioned by Odumbar, Satish Wani, slender columns for seismic forces and all soft stories. Right. So when we see the footages, we would see that the columns are relatively slender. So that is one of the reason. Santosh Kumar is saying that it's a brittle failure. Okay. Anwar is saying that foundation failure, improper geotechnical investigation or implementation. Ashita is saying that maybe building is not earthquake resistant. Okay. Okay, Gulam is saying that during construction stage, failure means question arises for the incorporation of construction sequence analysis in the design. Yeah, that's very important. Like when building is under construction now, at that time, whether partially, whenever structure is even not completed, whether it is able to sustain the earthquake load. Right? Soil liquefaction is one of the reasons said by Vaibhav. Okay, Benon is saying either a design error or poor workmanship. Okay. Padam Kumar is saying that interested in tall building design. Okay. Dr. Harpal Singh saying that natural frequency of the building might have coincided with that ground shaking at that place. So when the natural frequency or natural time period of the building and when the earthquake shaking motion are generally nearby, we can say that. So at that time, amplitude will increase, and that will increase the forces on the structure. So that's one of the reason. Design flows in seismic loads. Okay. Okay. Need to know the structural audit report of the building. Yes, of course, that's very interesting thing. The detailed forensic investigation is under progress, and everyone is looking towards that report. That what is the finding? Tejas is saying that high slenderness ratio of the building to counter seismic forces. Santosh Kumar is saying that return period of surface level of strong earthquake level. Okay, Sunil Verma is saying that earthquake does not fully explain the collapse. Investigations have revealed several contributing factors: structural deficiency, substandard materials, regulatory oversight failures. Right. So when we look at reason for collapse of the structure, so what happens? There is only, we can say, a single reason which might have triggered the collapse, and then there will be other reasons or other deficiencies of the structure which will contribute towards the collapse. Right. Structural design mistake. That's what Rakesh Kumar is saying. Kelkar is saying that how India. Okay, that's not problem. Okay, story dripped, said by Nisant. Sankalp is saying that front columns seems to be very slender. It may be soft story, not software, but it is soft story failure. Amarjit Singh says that lack of proper ductile detailing as per the codal provisions. Okay, reason for failure is not providing sufficient amount of reinforcement and maybe bad quality of concrete work. Okay, Anis is saying mechanical couplers and soft story. Okay, so we can see now soft story is repeating at number of places. Right? Of course, Bharati is saying that due to structural vulnerabilities. Maybe Krishna is saying maybe we can say improper or inadequate ductility. Right? Ravi Kumar is saying that the seismic waves were amplified by Bangkok's soft soil, leading to the building's collapse. So we can see 3-4 participants have said the collapse is triggered because of the we can say or rather it is contributed to the geotechnical failure. We can say. Okay, soft story and punching shear. That's said by Chandra Bhan. Pratik is saying that most likely the slender columns and the soft story. Okay. Nigel is saying that underestimated seismic force. Okay. Amal is saying that as an under construction project, the tower lacked finished non-structural elements, cladding interior walls, may reducing its stiffness and continuity needed to resist the seismic force. Of course, we do not consider all non-structural elements for the purpose of resisting the earthquake load, but definitely we can say that non-structural elements also contribute towards the stiffness of the structure. So we might say that certain part of the structural system might not have been completed in totality. That may be one of the reason, except we can say non-structural elements. Okay, poor construction management said by Hitmund. Geeta is saying that column buckling at the ground floor. We'll see all these reasons. We'll see once we get into the slow motion mode. Okay. So, okay, Rakesh is saying possibly swimming pool on top of floor. So this was under construction. Of course, on few other buildings, swimming pool was there, and where we could see the splashing of water. But on this building, as per my information, I think there was no swimming pool because it was under construction. Okay, nonlinear sway by Professor Mainak Ghoshal. Jay is saying that, okay, is eager to learn this. Deepa is saying foundation unrest triggered soft story due to mass and stiffness imbalance as the building was under construction. Okay, Dr. Ajay is saying that improper design or lack of execution precision. Okay, Sunil Goel is saying that poor design, poor structural configuration, and poor execution, etc. Okay, okay. Abhishek is saying that the soft clay layer in Bangkok amplified the surface vibrations associated with the high shearing forces, since the soft clay had a very low shear strength. So again, it is contributed to, let's say, soil failure. Non-ductile frame, Kazi says, okay, Neeraj is saying inadequate material strength, improper detailing, lapping, anchorage. So ductile, non-ductile detailing, we can say. Wrong construction practices, Meda is saying. Abdul Malik is saying that actual earthquake force may be higher than the design earthquake force. Okay, Prasad is saying that collapse on some of very weak members leading to entire collapse in form of progressive failures. Okay, Alan is saying that it may have been the result of poor practice, workmanship in structural layout connections, error in making design assumptions, inadequate supervision of work, and a lack of adherence to the design principles and codes of practice. So that's what we were just discussing, that there may be multiple reasons, in fact, contributing to the failure of the structure. In fact, I was involved in a forensic investigation of a few projects. So we had to find out which is the trigger point which actually triggered the collapse of the structure. And then there will be, in fact, multiple factors which will contribute towards, we can say, complete collapse or failure of the structure. Okay, Nazir is saying that no dampers provided. Okay. Mosaib is saying green concrete. Okay, green concrete, that means concrete might not have achieved the full strength. That's what I understand. Okay. It may be due to incomplete construction, Manohar, right? So this all we have touched. Kaveri is saying that the column might have been too slender, which would make them prone to buckling. In addition to this, there is a chance the design itself had issues and maybe the slenderness wasn't properly accounted for, or the loads weren't calculated correctly. Okay. Jokaim says that it's a design fault. Okay, Rupam Kumar is saying that column slenderness, facade fixing arrangement issues. Okay, so this is something new. Vikas is saying that compromise on design and ductility. Okay, Tanuja is saying that flat slab, inadequacy in tactile detailing. Okay. Okay, Arun has said very interesting point here, that this may be inappropriate strength of material of concrete, material of rebar steel at the lowermost floors, stress concentrations at the slab column junctions having bonded post tension cables in the slab, which might have failed before the rebars due to less allowance of elongations after readily stressed to 0.75 times FULT. So that's the case, right? In fact, whatever reason we are putting right now here, these all are guesswork. It's just probable failure. So what could be probable failure cause? That's what we're writing. It's not perfect. It's everyone is making guess right now. So that's fine. Okay, Yusuf is saying that the vibration of the earthquake reaching the resonance frequency of the structure probably assisted by poor workmanship. Yeah, so the natural time period and the average time period of the ground motion, both where we can say nearby, that's what he's trying to say. And of course, then the poor workmanship, which assisted this failure of the structure. Okay, Femi is saying it seems that the building was not designed for seismic loading. So when an earthquake occurred, a rigid structure frame collapsed. So it was kind of a rigid failure, right? It was, we could not say the big building is completely swaying like this. It's a rigid failure. Okay, Catherine says it's a collapse of soil. Okay. Abdul Kalam is saying that earthquake forces might not have been considered in the structural design. Okay, ignorance of design standards. Jitesh says. Likhon says of poor detailing and construction, poor design. Tanmaya says, okay, wants to learn. That's good. Deepauline says sob story at the ground level, right? And connections of the reinforcement. Kaushal says that failure of vertical member columns or walls under the lateral loads. Okay, Bahubali is saying low column capacity. Rekha Srishta says the to know the reason, of course. Okay, she wants to know the reason. Arun Kumar says that not paying enough attention to codes, designer, not done analysis adequately, and the soft story effect. Okay, demand more than capacity. Abhishek says. Rushikesh says weak lateral force resisting frames. Alidot says poor quality material. Okay, Rambabu Prasad says multiple points here. Okay, so first of all, there is a lower column failure. We'll see. We'll try to analyze everything with the slow motion videos after this file. First of all, it says failure likely began in longer columns on the lower floors, which are structurally more susceptible to buckling or shear under the lateral load. And also lower stiffness causes soft story failure. Then there is a sudden shear failure. As per video footage, it shows the rapid column shearing. We'll show this, we'll see rather this you must have seen, but we'll again try to see. And there are some interesting things which I've collated, which we'll discuss once we finish this file. So column shearing is, of course, it is quite evident into the video footage. So it is suggesting a brittle failure in the vertical load-bearing members. And finally, there is a failure mechanism. It's a progressive collapse. A cascading failure likely occurred after initial failure of critical components. Brittle failure mode, it's a sudden collapse without any warning. And structural system vulnerability. So basically there is a flat slab system which is used, so lack of beams. And it is known that flat slab system generally performs poor into the earthquake events. Okay, Syed has said compression failure, vertical member exceeds the capacity, so it's a column failure. Balram says that the construction quality and the material which are used, so whether building codes were adequately followed or not, that could be reason. As Guru Kiran says, soft story, maybe strong beam and weak column is not considered. So basically ductile detailing is not done. That's the point which is made here, along with the soft story. Appropriate earthquake consideration in terms of structural design. That's what Cheng is saying. Nicola is saying that distance between the center of rigidity and center of mass causing the building to twist and the columns to collapse on one side of the building due to second order effects. Very interesting thing. So what is said that the whole building is twisted. So maybe we can say that the first mode is the torsional mode. So during seismic event, the building is twisted, and that triggered the collapse on one side of the building due to second order effects, right? Yogesh Pandya says, okay, wants to learn. Great, that's great. Manoj Kumar, shear link and progressive collapse. Okay. Okay, Levis is saying lateral torsional buckling. I think he's also pointing to same torsional mode, probably. Suresh Kumar is saying that the RCC or composite columns poor quality may reach beyond the maximum considered earthquake level, and unfortunately no other buildings have this impact. Yeah, that's right. So it's only this building which had this catastrophic impact, or we can say it collapsed completely. Okay, Shivas Karki saying progressive collapse. Okay, yes, Chauhan can share the details if he is online. Dr. Rashma says that displacement occurred due to resonance of the structural members and failed to resist the forces occurred due to this, and absence of shear core walls could be another reason. Right. Okay. So there is one more reason coming up, which is a failure of mechanical coupler. Okay. Abu Jafar says. Temili says maybe codal provisions might not have been followed. That's what I understand from this single word. Madan Mohan says design failure. Okay. Saurabh says not proper design for seismic, so adequate design might not have been done for the earthquake resistant design. Okay. Tedang says that it could be unprepared analysis condition facing the immediate earthquake load. Yeah, possible. Okay. Bhim Rao says improper soft story column ductile design. Guru Prasad says estimating seismic effects. Okay. Shakir says there can be numerous reasons, but one main cause may be the negligence of soil structure interaction, and also there may be less stress on the ductility performance of the whole structure. Okay. Failure of long columns, Rahul says. Okay. Sandeep says column and beam foundation might not have been designed considering seismic, and also they might have used low quality material. Okay. Okay, Mohammed says that columns at the bottom front looks very slim, and those may not be able to take the load, and that might have been triggered the collapse. Okay. Mohammed says that lack of design considerations such as construction sequence or poor construction. Rajdeep says slender columns. Dhaval says Sob story, we can see now the pointers are repeating. Design failure, okay. Soil failure, Abuk are saying. Uncontrolled vibration. Prakash is saying that inner core is floated type due to parking arrangement. Below that core, same system known as transfer floor in India, various mega city. Yeah, I think it's trying to say that inner core was a floated type, maybe due to parking arrangement, and that might have triggered this collapse. Sridhar says substandard material. So it is found that one of the steel rods used in the building was substandard and came from Chinese company in Thailand. This factory had been ordered to close since December 2024. Harish Patel is saying that slender columns, soft story, and eccentric core. And first mode could be torsional mode, yes. Slender column and coupler joint failure based on Sachi. Wasip says that from his perspective, the collapse likely stems from the two key issues. First, the building was sitting on a very soft alluvial soil. So basically, it's a geotechnical failure. That's the first issue said. And secondly, the strong indicators that the seismic isolation system, such as base isolator dampers, were not there. And of course, a thorough forensic investigation will be needed to confirm the exact sequence of events. Absolutely right. Okay, it's progressive collapse. Pratik says, Nidhi says, the provision of flat slab system could have been the reason. Buckling of the columns. Priyan Su says, sob story. Aishwarya says, the splashing of water in the pool at the top may have caused extra force in the structure. According to me, I think water was not there in this building, as far as my information is there. Varang says that slender column, coupler failure, punching shear failure, and frequency building might have matched with the earthquake. Okay. Libin says four-story high columns that possess low lateral stiffness and insufficient shear capacity, which could lead to shear failure in the columns. And this failure could trigger a progressive collapse of the entire structure. Yeah, absolutely right. So column is very vital element in the structure. If even one column gives away, the entire building will collapse. The collapse may have been caused by inadequate structural design or seismic forces and poor construction practices that compromised the building stability, and material quality issue also may be there. That's what Akash says. Okay, Lakshmi says that the long column provided at the front of the building are not sufficiently strengthened as required. And that columns could have given away, and that might have triggered the progressive collapse. Prince says that failure could be as a result of the improper design. Yogita says forces were far higher than the design for. Govind says structural analysis, okay. Rabina says that I believe that this is due to problem with structural integrity and a lack of structural evaluation prior to approval by various authorities. Nerila says resonance. Anjala says poor construction quality, improper anchorage of bars. Pauline says it could be either missed errors in the structural design aspect, flaws, or in the execution compromised materials. Santosh says, okay, not studied, no problem. Sudarshan says stilt story, weak columns, and successive failure of columns, one after another. Right. Okay. So I collated this information before 2-3 days. So if you have registered recently for the event and if you put up your reason for the failure, I have not collated. So if it is there and if you are participating, please feel free to mention into the chat box. We will discuss that. So this is what the information which we have received through the registration from, and I would like to thank each one of you to put your understanding about failure of the structure, and of course, as far as the detailed forensic investigation is concerned, only that can reveal what could be the exact reason. But this I think one of the good source of learning for the structural engineering community. So I will appreciate that all the input which whatever you shared here. And I think each reason definitely is a vital and could be could be failure trigger for this structure, right? Now let's try to analyze these short clips, whatever we have, in a very slow motion, and let's try to identify a few interesting things from this, right? Okay. Chauhan is saying that the way it collapsed, maximum possibility of collapse if triggered from foundation level, maybe due to punching or tilting. Okay. Okay. Neeraj Singh is saying maybe due to repeating earthquake and higher intensity. Okay. Okay. So let's try to put up this. Now, this same clips, I have tried to put it into the very slow motion. So again, let us start with the view number 1 and 4. So we're looking at the building from the view 1-4, same building. Now building is intact up to this point. Now just observe on this side. So this is the side we can see. Okay. Now here we can see the failure is initiated on this part. We just go a couple of frames back here. We can see this entire building is intact. This part is intact. This part, in fact, remains intact if we see in this entire frame. The failure is triggered in this part, as well as it is triggered in this part. So that is captured into the next frame. So let's move further now. So now we can see here when the failure was triggered in this portion. Now this portion we can see relatively this is intact. And when we come to the next frame, we can see here the glasses are also broken on this side. So the failure is triggered on this side as well as on this side, right? And now if we move this clip ahead, okay, now we can see. So this remains intact. This portion remains intact. And we can see that building is tilting, right, in this side. So it's like tilting in this side. Okay, it's actually left and right. So it's tilting on this side. So it's quite evident from this that there is some failure which has occurred in this portion, right? In these two portions, in these two corners of the building. That's what this clip says now. If we move this further, so that's a complete collapse, right? So this is from the view number 1 and 4. Let's see the view number 2. This again, I have made it in a very slow motion. So we can see here now, I'm just pausing here. Now here we can see the failure in this part. Right. So it's quite evident that there is a failure happening in this region. And if we move this further, now remember we are looking from the view number 2. So if my marking of view 1, 2, 3, 4 is correct, So I'm presuming that my marking is correct. So this is, let's say, view number 2 as per, let's say, our side, right? So firstly, we just looked at, previous to this, we looked at structure from 1 and 4 view. Okay. And now we're looking the structure from the view number 2. So in this, the structure will be actually collapsing, right? So we can see here that it remains, of course, we can see that the initial failure we could see if we focus only on this view, we could see some failure occurred here, right? Because we can see the dust particles coming out from here. And we can see very clearly the columns are also dying, and we might be able to see, yeah, so on this side, now we can see that now this is complete failure on this side. Now let us try to see the view number 3 again. View number 3, that means we are looking at structure from this direction, right? So from the, so in the view number 3, we have two clips. In fact, one is at the bottom of the ground and other is at the top. Right. So as you can see how there are two clips. And again, I'll keep on mentioning this disclaimer that all views are written based on my understanding, based on after looking to this clips several times. So my understanding may not be correct. So now what we're looking at, it is a view number 3, and this is from the top portion. Now let's move this clip in a shorter way, or in a smaller scale or frame by frame. Okay, now here we can see this, if we focus on this point, you'll be able to see that this portion is coming down. This portion, right? This portion is coming down. If we go 2-3 frames ahead, we can see this entire crane also. If you focus on the crane also, the crane is also coming down. If we just start again, right? So, okay. So if we just go a couple of frames back, so here also we can see when we look at structure from the view number 3 also, we can see that something has occurred in this portion. Right, and then we can see this portion is going down. The screen itself, which is supported on or near to this shear wall, we can see this entire portion is going down, and that has created stresses into this portion of a beam and slab junction. And then after a certain point of time, there's the slab and beam junction have given away. If you see this clip again, right? See, until see it comes down, this portion comes down, the structure is intact. The failure is noticed at this point when there is an exaggerated displacement which is happening in this region, right? So then and then we can see that the failure is triggered here in this portion. If we go further by 2-3 frames, yeah. So now this is also very interesting thing. Now just see this entire line. Now we can see this entire slab. So earlier it was in the straight line. So what does it mean that this column has given away? Now this column has failed. So if you remember in the view number 3, now that's what I'm considering. We are looking the structure from the top side. Now we'll be looking the structure from the bottom side. And this clip you must have seen a number of times, wherein this column is failed first, and then this column is given away. So just observe what happens after a few more frames. This line is inclined, right? This entire slab has become inclined because this column has given away, but this column is intact. After a few seconds, if we move further, see this connection itself is gone. And then because of the gravity, once both the columns have given away, this will come up nearly into the straight line. Just observe this slab. It is coming nearly into the straight line because now both the columns have given away. So see here, now it is coming into the almost straight line, even if it is collapsed, because both the columns have given away and now it is coming down directly, let's say, under the effect of gravity. Okay, so then there is a complete collapse. Okay, now this is a classical footage, and this footage you must have seen a number of times. So this also, let's try to play on a shorter scale. So when this clip was taken, we can see that people are running out. So when this clip starts, we can see that the building is intact, but we can see that people have started running. So that must be some sound must have been coming into the building. Maybe the failure of glass or failure of some structural elements, which might have triggered some sound. And because of that, they have started running. So the clip which we are looking right now, at this time, still building looks intact, right? And now let's move it at a smaller scale. Still building looks intact. Okay, the same clip, I reduced it into the very slow motion. So we are looking into the frame by frame. Okay, so this is the point where we could see here, there is a failure of this column. This column is given away. But what happens before failure of this column? Now, if we just go back, if we try to analyze it again. So when this column is given away, and if you see few earlier frames, and this is what my understanding is when I was looking this clip closely, this is what I found And as per my understanding, what I could see here, that this column or this portion has started sinking. And if you see this portion, so this is actually supported on this column, or maybe there could be a shear wall which is inside, right? So if we just go back to the previous frames, we can see that this is completely straight, right? This portion almost straight, we can see. Even this line also, if you see this black color line also looks almost straight. Now, before the failure is triggered into this column in this region, if we just investigate the frames, okay, that's it. So this is the point now where this column has started giving away. But exactly at that point, now we can observe this line. Right? So according to me, there is some settlement which might have occurred into this region in the corner of the building. The view number 1 and 4, which we were looking, the two corners where the settlement could have triggered. Right? That's what is my study based on when I looked at to this uh, let's say eclipse number of times. Now when we move further, of course, once this column is given away, we can see that's why the whole building is giving thrust on this side. So if we just move further now, so now this column is given away. And once this column is given away, so then we can see there is already the big damage which is occurred to the top. And of course, now this column are also on the verge of failure, we can say. So if we move further, so now this columns have also failed, right? So maybe as per my personal finding, of course, I would not say that this is the uh, perfect finding. It's just based on the uh, this clip, based on this few angle, or let's say few second clips what we have, in absence of any structural drawings, in absence of any geotechnical investigations, etc., in absence of any other reports. This is what prima facie it appears that settlement could have occurred into the building in the region of let's say region as we've just marked here. Let's say this is the region. And similarly, the settlement has occurred on the next side of the building. And here also we can see that the glass is getting broken, right? So that settlement must have occurred on the other side also. Okay, there is one more thing. If we see here, the glass have already started broken when still this column is intact. So if we just go back to one more frame, right? So in this one more hint which we're getting here, this column is intact, this column is also intact, this column is intact, but at this time we can see this glass has failed, and here also we can see some dust coming up. So that means, so it shows that something has happened in this region, and that is actually triggered the collapse of the building. And then of course, this collapse of the building was assisted because of this slender column. Maybe reinforcement detailing could be problem, maybe material quality could be there could be n number of reasons. But the prima facie, the smart is appears that on one side of the building the settlement could have occurred, and then that differential settlement could not withstand, or other structure could not withstand that differential settlement, and which actually gave failure of the columns and then in fact there was a complete collapse of the building. Okay. 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 So now I'm making this session open for the discussion. So just let me stop sharing and now if you want, you can simply unmute your mic or you can put the points into the chat box and then we will take up one by one. Let me share. Stop sharing. Okay, let me share the screen also parallelly. So if there's any relevant question, we can open the document also. Yeah. So now please feel free to share your points. Okay. Okay. Deepa says the building is tilting towards view one and tension is created on four long columns at view three. The column cracked and sheared off in tension and hence sudden collapse occurred. Yes. Okay. Varun says yes, sir. Super observation, sir. Okay. Thank you, Varun. Varun says maybe soil displays occurred at the shear wall place. Yes, definitely that maybe at the shear wall location, or maybe at the location of this column. This see here also it appears as a column. Maybe this one, this column. So at this column location also, maybe the settlement could have occurred, or the foundation which is supporting this column might have settled with a relatively larger dimension. Yeah. Okay. Please feel free to mention anything in the chat box, or let's say if you want to share something, please simply unmute your mic and we will discuss it. Yes. Okay. Rambabu Prasad, you want to share something?
Uh, I am thinking the problem of liquefaction.
Yes. Yes.
Mm, Also, I want to know what type of foundation they have used actually. They have
Hmm.
used, it have pile foundation, or they have used the deep raft.
Hmm.
And so, uh, as per the, as you have shown very nicely, sir, the view number three,
Hmm.
and the building is sinking from in view number two, side view number two,
Yeah. View number
probably.
three. Three. Three.
Yes, sir. So I think this is the problem of liquefaction, sir. There will be liquefaction, and as per some report also, while some study also, they have given that there will be problem of liquefaction. So this is the major problem, I think so.
Yes. Yes. Absolutely right. And that's what if you remember, that's what we were discussing in our last let's say discussions for foundation engineering. That
That's
foundation is very important.
so,
So let's say as far as structural analysis and design is concerned, I would say it is more or less formalized. When we create the sophisticated computer models, when we apply all different wind load, seismic load, etc., we apply factor of safety, etc. But when it comes to the geotechnical investigation, when it comes to the soil behavior, there are a lot of uncertainties associated with it. Right.
so,
Right. And once, let's say this higher settlement, and in fact, we were debating on this settlement, right? That what is the permissible settlement for the building? Now, if one part of the building goes for a relatively high settlement, then that could be complete collapse of the building, right? Okay, Dr. Ajay Kushal is saying that biaxial moments of peripheral columns and may sinking due to differential settlement due to liquefaction of soil. Yes, absolutely right. Yes. Okay, Yogita says that what measures or is there any possibility of saving such type of failures? Yeah. Okay, now here, let's say this, we are just creating wild guesses right now based on the CCTV camera footages we have. And let's, for a moment, let's understand that whatever finding which we have got right now is correct. So in that case, see, the proper soil investigation is required first thing, and secondly, the soil structure interaction, and that's what we discussed, debated to a great length in our last online course for the foundation engineering. And according to me, this is one of the areas. See, if we just look at to the study, I was referring to number of study, and then it is said that majority of the structural failures are actually attributed to the foundation failures because there are a lot of uncertainties which is associated with the soil. So to prevent such kind of failure, what should be done at a start of the project? We should, once we receive the geotechnical investigation report, we must have multiple dialogues with the geotechnical consultant. We should be able to understand the type of soil and then how it is going to behave in a different kind of scenario, maybe during different seasons when there is a fluctuation of water table, maybe during seismic events, what is going to happen, and if there is a potential of liquefaction, for example, on this particular site, then our foundation shall be penetrated well beyond good strata, or let's say at least into the good strata of the soil. So that even if liquefaction occurs, let's say foundation is supported on the well strata where liquefaction potential is not there. So even if liquefaction occurs, that it will not impact the structure. So in a very simpler words, I will say significant or effective interface is required with the geotechnical consultant to prevent such kind of failure, uh, or we can say to prevent foundation failure. Okay, RK says that liquefaction also affect other building. Yes, absolutely right. Okay, yes, welcome, Yogita. Okay, Dr. Ajay says that selection of foundation is very critical with geotechnical technical investigation. Absolutely right. See, many times it happens that geotechnical consultants suggest the foundation type in isolation. Even sometimes they don't know what's the type of building and then how much load which building is going to transfer, and on let's say particular column level, approximate level of loads also they don't know. So sometimes it's a kind of a copy paste report which they just submit, which may not be suited perfectly for specific projects. And that's why I said we must have significant and effective interface with geotechnical consultant to arrive at we can say the most efficient foundation system for the particular site as well as for the particular project. Okay, KP says that.
So,
Hello.
yeah, sir.
Yes.
Is it
Yes.
audible? Yeah,
Yeah.
sir. I would like to thank you for your invaluable insights on this case studies.
Most welcome.
And yeah, sir, it's as per my observation, it is like fully because one side of the building is getting settled, which is might be like because of the differential settlement, and also I don't think so. It's because of the liquefaction. If it is a soft clay, I don't know what is the soil property and what is the soil really beneath the ground. I mean, like beneath the foundation level. So if it
Very
is a soft clay, I'm damn sure that it is not because of the liquefaction, because liquefaction will occur only in the sandy soil.
yes, absolutely. And there's one more thing. Let's say when we talk about liquefaction, that's it's not only one part. We will say, the whole building will start. So here you can see just only in the one part where we can see that sinking is occurring, and
Yeah,
just nearby column is not sinking at all. So may not be full liquefaction effect. I fully agree with you, right? But it maybe because of the differential settlement, which
yeah,
could.
that, yeah, that's what. Yeah, that's yeah, yeah.
Yeah. Yeah, thank you.
Thank
Thank you. Yeah. Okay, KP says that along with differential settlement, as we see height of different floor, height from ground floor to top floor, the concept of sub-story and weak story ignore. Yes, absolutely right. So let's say, as we just discussed, the differential settlement could have triggered, and then there is a sob story, and the height is, let's say, very long between floor to floor. So there's everything combined, and then that was failure that caused failure of the building. Varun Kumar is saying that will there be any difference in resisting earthquake forces in other construction process? Okay, in the construction process and after completion of construction. Okay. Now say when the during the construction process, now let's assume if we see this building, at least we could see that majority of the structural elements are in place, like let's say a shear wall, column, slabs, etc. Right now, during construction, in fact, the loading on the building will be relatively very less because there is no mass, right? The mass of the building is lesser, so earthquake force is lesser. Whereas after construction, there will be a number of non-structural elements. Also, there will be presence of live load. For example, let's say this kind of an office building. It was, I think, kind of an audit building, if I'm not wrong. So let's say people are also there. So that lively load will also contribute to the mass of the building. And of course, when the building is fully completed, fully constructed, at that time, non-structural element also gives certain stiffness to the building, and that actually alters the time period of the building, we can say, right? And as we just discussed, the average time period of the ground motion and the natural time period of the building also play a certain part, because if they are relatively closer to each other, so in that case the amplitude get amplified, or we can say the force gets amplified, right? So we can say in both the cases, the time period value could be different. We can say the loading intensity also could be different. And during construction process also, let's say if may happen that certain element is not constructed 100%. That also could trigger a collapse of the structure, which let's say may not be able to provide full stability to the structure because of the partial construction, we can say.
Sir, one more reason I think that is the presence of flat slab. And due
Yes.
to the flat slab, the structural system that absence of beam, the load transfer has not been done properly. If suppose there will be proper frame, then
Yes.
differential settlement can be taken care by the structure little bit. But here they have used flat slab as we are seeing in the photographs. And
Right. Right.
so this is the we can say the poor structural system is also the reason of that.
Absolutely right. So
And one more thing, sir, in code, the sequential analysis should be given during during the construction period, particularly for high-rise building and important building.
yes.
Uh, because suppose this building was under construction and that has been collapsed. If suppose the proper care in design or the analysis could have been done for the sequential analysis, then it may be protected.
Yeah. Yeah. And of course, it again comes back to that point about differential settlement also. So that, let's say, we also need to, as we were discussing at a great length in the previous sessions, right? That we should know what is the value of differential settlement which we could get in the extreme conditions, and that settlement value we should apply and in our structure, and then we should see whether our structure is. Let's say is adequate or not, or rather it can withstand such value of higher settlement. And then, as you rightly said, the once we apply those kind of settlement, and when we perform advanced analysis, we will be immediately able to see that, let's say, the system is not able to resist the load, right? So it's actually combination of different causes which actually trigger the failure.
Okay, sir. Okay, thank you, sir.
Most welcome. Yeah. Okay, Levin says that If the collapse was caused by differential settlement of the mentioned shear wall or column, what measures would you suggest to prevent such differential settlement? Yes, Libin, same thing. I think you were also present in the foundation engineering discussions. So again, I'll repeat the same point that we must have effective interface with the geotechnical consultants, and then we should understand the type of soil, and then we must choose the most appropriate foundation system for the particular site. Right. And depending and then considering the different scenario, we should be able, or rather, we should calculate the differential settlement along with the geotechnical consultant by taking them into the loop. And that value of the settlement or whatever differential settlement which we are getting as, during the extreme conditions, that we can apply in our structural analysis also. Right. So,
Hello, sir.
yeah,
Am I
please.
audible?
Yes, you're audible. Yeah.
Yeah. Hello, sir. I'm Mansimran.
Yes,
And
Mansimran.
I just wanted to add up something that I recently attended an event at IIT Roorkee, and there were some professors which came from Asian Institute of Technology, Thailand, and they gave a glimpse of something that which really provoked me. They said this kind of phenomena which has happened this time is actually unexplainable till yet. They haven't found an explanation yet, because what happened is, like, they had the earthquakes of like 5 to 6 time period or something else, but there is something in this earthquake which was like 6 seconds something. I don't remember the actual term. I had that. I'm just having that graph in my mind actually now.
Yeah, please go
And
ahead.
yeah, and one thing more was, they found that this particular building only collapsed, which was actually 1,000 kilometers away from the main epicenter.
Absolutely right.
And that is the most amazing part of that. The epicenter and the closest building to the epicenters were not at all collapsed.
Mm-hmm.
We have seen the videos of that twin tower, which had that swimming pool and the bridge, which collapsed in between them. But they did not totally collapse, but this building particularly collapsed. So they are now telling the Thailand government that there should be some time period devices installed in each and every skyscraper building in
Yes.
Thailand. And one thing else, one thing more is, like, now they are going for a major change in their building design codes also. But they are researching on, like, what parameters do they have to really consider. And moreover, they said, like, soil was not the main criteria which made this collapse. It is something else. It had to, this is totally linked to the earthquake and the way it traveled. I mean to say that this earthquake, I mean to say that aftershock and multiple earthquake terminology, it is going into that side only. They are inclined towards that particular uh,
Yeah, I'm
philosophy.
hello.
Yes, yes.
Yeah. Okay. Yeah, please go ahead. So have you finished it?
Yes, yes, yes.
Okay, thank you. Okay, thank you for sharing the input. Yes, you're absolutely right. There could be a number of reasons, and in fact, I was investigating that what may be the failure or what may be response of the structure when we consider multiple earthquake events. Now, in the recent earthquakes, now it is observed that even aftershock are also of the relatively same intensity, kind of a major shock. Right. So what happens? Let's say one the building as let's say once the earthquake striked, and after let's say few minutes or let's say after 1 hour again earthquake comes. So at that time, earthquake strikes on the damaged structure, right? And that is really creating damage. Now all our international codes are silent on that part, which we can say which is the sequential earthquake, right?
Hmm.
So Okay. Now, one more thing, as you said, definitely that is very interesting and very important. Like whenever generally when we consider the average time period of the forcing frequency of the earthquake motion, then it will be very, very short. Frequency will be very high, we can say. Uh,
Yes.
or we can say the time period will be, we can say very short in the near far
Shorter.
field, shorter
Yes.
period. And when
Yes.
we travels to, let's say, longer distance, at that time, the time period value will amplify. And that time, this time period of the building and the time period of the earthquake motion. So even if it doesn't coincide, but if, let's say, if it is nearby some value, so
Hmm.
then there is a sudden peak into the forces which is getting transferred on the
Yes.
structure.
So I remember the graph. It was like it was having the peak in the initial earthquake. It was like 1 to 5 seconds. There was a major peak, and
Mm,
then the graph is turning downwards. And at the moment of 6 seconds, there is another peak.
mm, mm,
It's a very short one, but there is a peak in forces, and that
mm,
is what which has it caught their eye, that
mm,
there is something between this particular time period only, and this we haven't investigated as of now.
mm,
So ultimately he said that we tried to explain this phenomena with every possible knowledge of earthquake we had in AIT, but we couldn't. So now we have to find something else, that what actually triggered the collapse of this thing.
yes.
As of now, they don't have any convincing reply or convincing explanation of this whole event.
Yeah, yeah. See, I also try when I just looked at this for the first time in the social media. I was also surprised, and then the different views started coming up. Different view, that means different angles, which I've just taken one, two, three, four, and I was also getting puzzled, like why I could not.
Hmm.
It was not fitting. Like why this building failed, and every view was telling something different. Now, why
Yes,
by making it a very very slow motion view? This is what my finding is, that which I just presented. This could be one of the reason, right? And which is evident only from this small clips what we have. Of course, there is no, we do not have access to the foundation drawings, geotechnical investigation reports, etc. But
exactly, sir.
definitely detailed forensic investigation is required, and which will definitely come out as a final report. And I think we all should look forward to it once it is published. Yeah.
And one thing more, sir, I just wanted to give a clarification about, because this was something which was discussed in that particular event also.
Yeah.
Many of the participants asked that is that the sloshing of this swimming pool water giving any relief to the structure, or giving anything any bad effect or not? And the straight answer to that particular thing was that no, not at all. Swimming pool cannot act as a tune mass damper, which we actually think it will, but it
Mm,
doesn't. It
mm,
never will. And
yeah.
if it has to react like that way, the amount of water the building we have to store in that particular building is like huge. That will be
Yes.
like another headache.
Yes. Yes. Yes.
So it was repeatedly asked in this particular session also in the chat boxes, and at Roorkee also this was came up a few times. So just I wanted to clear that it cannot.
Yeah. Okay. Alan has raised a hand. Yeah. Please go ahead, Alan.
Yes, it appears. Thank you very much
Yeah.
for
Most
this
welcome.
session.
Most welcome.
Uh, in looking at the number of videos, the failure appears to be similar to that of a demolished building,
Mm,
which, in my view, appears to be that it's disastrous. But I've seen on Wikipedia and other analysis by other engineers who have indicated that with regard to the soft story elements, when people have analyzed the structure based on the photographs,
mm,
etc., and the
mm.
columns were up to 60 Newton uh, per square millimeter, the strengths. which would have exceeded most structures. Only significant, well-designed structures with high-strength material would have been able to sustain it.
Right.
Besides that, there are procurement issues that we note.
Yes.
This is very, very, very. This is a failure that is internationally going to have lots of waves.
Right.
Yeah.
Right. Thank you. Thank you for sharing. Yeah. Yeah. Alidod, yeah, please go ahead.
Yeah. Good day, Mr. Shah.
Yes. You are audible.
It is nice to hear about the soil, but what about the columns? What about the seismic form? And I think it is also we should speak about form, because you see the column is thick, and when the shake coming, and from the seismic part, it is like not irregular form, regular form, but it's not. Our colleague before, he mentioned about another building which have a swimming pool.
Yes.
It was a normal shaking. It was in X direction and Y direction, but
Right.
here it was like it's how can say, it was not in a really nice direction. And this is the first part. And the second part, Mr. Alan, he shared some link in YouTube, and I think it will be better if someone from our participate have real protocol or real document which they have, because in internet it should be fake photo or fake something news. I mean, if our colleagues have something real document which come from government, from this country, or from our colleagues, it would be nice.
Absolutely right. Yeah, thank you. So yeah, you made a very important point here about the columns. So that's why when we talk about earthquake resistant design, the entire thrust is on the sizes of the column, and we want to make columns as strong as possible so that it doesn't become a weak link. Now, unfortunately, we can see in this building, we can see that the buildings are relatively very slender, and this was mentioned by many of the participants into the registration form also, right? So if we have the slender building, then definitely there is a possibility of column becoming as a weak link. And once at least one column fails, then we could see from this example that the entire structure will collapse. And secondly, yes, definitely we must wait for the official documents when those are getting released. And we will definitely have one more discussion once we get more information on this.
Good evening, sir.
Yes.
Sir, just for curiosity, I want to know what are the steps and methods are used for detailed forensic investigations?
Okay, forensic investigation, let's say if we talk about at least in India, right? Say I worked in a few projects, and I would say it is not very well organized in India, I'm talking about, right? But let's say, just to answer your point, like what are the steps involved? Of course, let's say the first step will be, let's say where I was involved, and then how we did it. First of all, we'll try to see how the structure failed, right? So let's say when we went to the site, we took at that time, in fact, we didn't have this technology of CCTV camera, let's say capturing the images, video. So what we had only the debris of the structure, spread around the site. So we went on the site, and then we plotted, and then we try to visualize by making certain drawings, animations, that how the structure could have collapsed, how the structure would have failed, right? That's the first thing we did in the forensic investigation. Secondly, we'll take the samples of materials like concrete, steel, etc., from those debris, and those will be tested, right? Then the third thing will be done is the study of the structural analysis drawings, details, calculations, structural design basis, geotechnical investigation report, right? And then based on the failure mechanism which was observed by let's say plotting, by creating a 3D model. In fact, we also performed then few advanced models, maybe non-linear analysis models, buckling analysis, etc., to replicate the failure mechanism or the failure pattern, the way the building has collapsed. And then we try to see the different parameters, or rather, let's say, different elements, how they are detailed, how the reinforcement is detailed, etc. And based on that, the reason is found out, right? And of course, that the reasons could be sometimes in few projects it came out that design was up to the mark. It was the substandard material which gave away, right? Which was a problem. In one of the structure, it happened that there was no cover provided at all. So cover was very thin, and because of that, there was a corrosion. So even if structural design was perfectly done, but structure was old. Let's say it was 15-20 years old structure, and it was a water retaining water tank, large water tank, and then it collapsed. It collapsed, in fact, because of the corrosion. Right? So the entire purpose of forensic investigation will be to find out the root cause, and it is in fact very difficult exercise. But this will be general broad steps which will be involved.
Very informative, sir. Thank you so much.
Most welcome. Yeah. Okay, Harish saying that beams are of very small depth, okay, and so system is like flat slab and core with perimeter column. So in my view, under heavy shaking, the connection of flat slab and column has given away. Okay, has given away first, and then progressive collapse has started, and outrigger and the bale truss might be a solution to this problem. Same controls dripped to great extent. Yes, definitely right. The connection between the slab and column has definitely given away. Slenderness ratio of column is also maybe problem. Yes, definitely that we have discussed. Flat slab is definitely a problem. Then due to uneven load transfer on the foundation, yes, definitely that could be the reason, and that could have triggered these differential settlement. Okay, but only saying that why this structure is not laterally swayed. See, that's the important point. If structure is detailed properly, and let's say if the properly detailed structure, they will sway like this. If you will see the animated, not animated, but the actual videos of the tall buildings when they are getting, let's say, getting displaced due to earthquakes, you will see that will shake like this. But here, we could see that there is a significantly larger differential settlement, as it is evident from this, and probably that might not have allowed, you know, the what we would see the ductile behavior of the building. Right? And it in fact resulted into the brittle failure. So of course, these slender columns, maybe inappropriate reinforcement detailing, the height of the column also what we see is a higher. There are all different factors which in fact contributed to the brittle failure. So the failure is brittle failure. We can say it's not, let's say, the exaggerated displacement which we can see in the structure. Okay, what is the most mode failure of that particular column in the sunken part? According to me, that portion, that let's say this column, or let's say the shear wall started sinking, and that differential settlement as triggered, right? So we can say that is the higher settlement or as a failure mode for that particular region. Yeah, I was literally shocked to see the column dimensions at the ground floor, the structure failed in gravity, let alone wind and seismic. Yes, absolutely right. Okay, AC guidelines for forensic engineering practice second edition is helpful. Forensic structural engineering handbook, Robert Trier guideline, and the approaches are stated by Bhavin Shah. Thank you. Okay, antidote says that Mr. Alan, do you have some documentation or protocol about this building? It will be helpful. Okay. Okay, Harris is saying that beams are of very small depth, so system is like flat slab and core with perimeter column. So in my view, under heavy shaking, connection of flat slab column is given away. Okay. Okay, Harris is saying that as in your slow motion video, columns were okay, but slabs were coming down first. Yes, definitely. So the slabs were coming down first, and those slabs are actually connected to the other side of the column. That's what my assumption is, right? And that column is settled down, or that column, or we can say that portion of the shear wall started settling down. Okay. Okay, thank you all for the participation and to have the interesting discussion on this.
Mr. Shah, can I for a last question, if you allow me to speak?
Yep, most welcome. Please go ahead. Yeah.
Yeah. As some gentleman was saying that the buildings which are closer to the epicenter was not been collapsed. However, which are far away from the epicenter, they have been showing those structural signs.
Yes.
What I just wanted to appraise and share my knowledge to it is there is a most of the thing which we forget as a structural engineer and design engineer, that the orientation of the building from the epic center, what kind of a seismic wave coming from which side. Let us suppose we have a 100-story building and we have a cylindrical kind of a shape of the building. In tall
Okay.
buildings you don't have the lateral dimension much more, right? So
Mhm.
that's how it is called a tall building. So
Right.
if that seismic forces are coming from the shorter lateral side of the building, that would have been more destructive. If that would have been coming from the longer direction of the building, for which it the stiffness is giving more a part to resist it.
Yes.
What I like, other gentlemen are also telling the things that the flat slab and beam the column joints are failure. It is just because of the because see, if you see the analysis part, the stiffness has very critical relation to the force applied on the building. That is, force is equal to k by l, right? So
Right.
what I mean to say is, if you have a seismic epicenter to the shorter dimension of your building, that will be more destructive. If you
Right.
have a lateral dimension, long dimension in direction to the building, you will be having a more stiffness to the building to resist with. So I
Mhm.
think that is one part which we always forget while we are questioning the question. It is just for my part. Just want to share it with the youngsters, those who are calling the question. So
Yeah.
it is from my part. Thank you very much.
Most welcome. Most welcome. And thank you for sharing your input. Yeah.
Yeah.
Yeah, okay, I can see a few more points here. Okay, by saying thank you, most welcome, because the recording will be shared. Okay, let me see how we can publish it. Okay, Chandra is saying very enriching session. Thanks a lot. Okay, Libin is saying thank you. Good discussion. Okay, most welcome. Okay, with this, let us stop at this point, and we'll be definitely coming up with more and more interesting sessions. So just keep on following us. Okay, so with this,
Thank you, sir. Good night.
most welcome. Good night. Yeah. Yeah, and now, okay, next session. Okay, couple of few interesting sessions are lined up, but one of the session which we'll be having shortly, that is on IS 800 2007, not 2007. Now we can say proposed draft code for the IS 800. So there are very major changes what I could see, and I think at this time now this is the opportunity we have. We can comment, in fact, on all different parts of the entire code, even if let's say only few revisions which are made, but I think we have the opportunity to comment on all different parts of the code, and I think the last date is nearly around 16th May. Okay, so just keep on studying that draft document, and very soon we'll be meeting in this kind of session. Okay, so till then, goodbye. Okay, so we are disclosing this session.
Nice presentation, Mr. Shah.
Yeah,
Take it as a compliment.
yeah.
Thank you.
Thanks a lot.
Thank you.
Means a
Same.
lot. Okay, bye.